Welcome back to another quick tip. James and I are back. We are diving deeper into Semantic Link Labs. Hello, everyone. James,
Hello.
welcome back. Let's go do this.
Yes, let's do it.
All right,
Do you want
jumping
to tell
right
them a
in.
little bit about? Want to tell them a little bit about what we've got going on here as far as our Lakehouse first, since that's kind of a part of the setup.
100%. So let me give you a quick setup while James is getting his computer up going here. And this is going to be our notebook for today. What we want to just point out here is we are using another feature from Semantic Link Labs. This is a new feature that was released in 0.9, a recent update. I'm sure there's more updates since we last looked at it.
0.9.10.
Sorry, 9.10.
Yep.
Thank you, James.
Yep.
And then the idea here is we are using a function called save as delta table. So there's a function inside here, thank you, that highlights out the feature of that particular Semantic Link Labs option. Now, it's very easy to use this. You can do this in PySpark. In other notebooks, we are using a Python notebook today. And what we found in our testing was the Lakehouse that you're writing data into, this function, save as delta table, will only work with a Lakehouse that has no schema attached. So when you create your Lakehouse, you have the ability of creating a Lakehouse with and without a schema. There's a little tick box at the bottom of the Lakehouse creation screen. And if you use the schemas in the Lakehouse, this function does some weird things. It makes the table, but it doesn't quite make it accessible or easy to read through the UI. So there's something there that we may follow up with Michael Kowalski later on. But if you use a Lakehouse with no schema enabled, everything will work just fine. So just FYI, our setup here is using this feature with a Lakehouse with no schema attached. James, take it away.
Yep. Okay, so we're gonna start with anytime that you're using Semantic Link Labs, you do need to install it into because this is not one of the libraries that comes baked into the default environment in Fabric. So your first cell should always be this little command magic thing here. So it starts with the percent, and then it's pip space install space semantic hyphen link hyphen labs. So you run that. And basically, what this does is it runs that command basically as if it was a terminal command in your session. So we're gonna have run that first. Okay, cool, pretty quick. Next, we import our dependencies. We're gonna be using pandas for the data frames. We're using NumPy to do a little bit of random number generation. You'll see a little bit why we're doing that. We get SemPy labs here as labs. So when you import Semantic Link Labs, you actually get this thing called SemPy labs. That's this kind of a short name, and we're going to shorten it even more by importing it as just labs.
Correct.
And then we're also going to need because we're going to read back the data from this that we're going to write into the Delta Lake. We're going to read it back out. So we're going to import the Delta Lake, the Delta table from the Delta Lake here, so we can read that back out as well. Okay, so here's the documentation on this function that we're going to be using. Oh, I should probably run that import cell.
There you go.
All right.
There, now you got it.
So yeah. So when we run this function, the first thing we have to give it is the data frame that we've already created. So like I said, we're going to get to that in a little bit here. We give it the Delta table name. So it's a string, and then you also give it a write mode. So that would be either append or overwrite. Oops, didn't mean to do that. Either append or overwrite, right? And so that's you would want to give it the table name and tell it whether you're appending or overwriting it. And then your merge schema, this is just a true or false. The schema here, this would be like you go to dictionary and say this is the column and this is what data type it is. And then the Lakehouse here, you tell it either the name of the Lakehouse or the GUID of the Lakehouse. And the same thing with the workspace, either the name of the workspace or the GUID. And then what's going to happen here, if you leave it blank, it's just going to go with whatever the default is. So if if your default Lakehouse is, which is, what you'll see it as pinned here, that's your default Lakehouse, then it'll just go to that if you leave it blank. Same thing with workspace, whatever workspace you're currently in, if you leave it blank, it goes to that workspace. So you can also use this to write it to a different workspace, different Lakehouse if you want to. That's kind of a neat flexibility that this function gives you that we're not demoing today, but certainly we encourage you to try it out. So what we're going to do is we're going to do a little bit of cooking show magic here, I guess you could say. We're gonna have this thing generate some demo data for us. So basically, this is just creating a dimension and a quick little fact table full of random numbers. And so here's our dimension. It's got the ID column and then all these
Random letters.
random letters. And then here's your fact table. And you've got your various different columns here. And then here is the foreign key for the dimension. So if you wanted to join these two together, you could get a you could begin to create a star schema. So all right, now we're going to load these two data frames into delta tables. Now over here in the Lakehouse, you'll see there's no tables currently. So what we're going to do is we're going to go ahead and load that data that we just did up here. We're going to put that in the Lakehouse. So we're going to start with, as mentioned earlier, we shortened Senpai Labs to labs, so we do labs dot save underscore as underscore delta underscore table, and then you put all the parameters inside parentheses. So we give it the fact data frame as the first one, because we're going to start with the fact table here, and then we're going to load the dimension table. We're going to give it a delta name table name of fact foo. Write mode is going to be overwrite. Merge schema, we're just leaving that as false. We're not giving it a schema, and we're telling it the name of the Lakehouse we want to save into, and then we're not specifying the workspace. We're going to do the same thing on dimension here as well. So we'll go ahead and run that now, and we'll see.
And while James is running that, I'm going to just give you a quick little note here on like what does write schema mean, and what does merge schema mean. These are two really kind of important things in the data engineering world of what do those two options mean? So the write mode would be overwrite. And when you're doing an overwrite operation, you're basically saying delete everything that's there and replace it with this new bit of data that I'm going to bring you.
Yep.
The other option you can bring into the write mode is an append mode. So you can overwrite or you can append. And what append mode would do is it'd say, I'm going to leave the data that's there in place. I'm not going to do anything with it. And what I'm going to do is I'm going to append this new data frame. So basically the data frame that you're describing there, dimension df or fact df, those two data frames would be appended to the bottom. So in the append mode, you'd be able to just keep adding data to the same table.
Right.
Then when you go into the schema merging, there is this kind of concept of schema evolution, right? Let's say I'm adding a new column, right? Your new data frame may have an additional column. That would be a schema merge. I'm going to have, James, if you don't mind, go back up to your tables real quick. Let's just quickly talk about a schema merge there. Here's good example here. Here's my dimension table. Let's say I wanted to add a column number 6. So dim column 6, that would then create a new column, which means the schema would have been different than my original. And if we say schema merge equals false, it'll fail the job. It'll say, nope, we can't have you. You don't have the right number of columns.
Yep.
We don't know what you're talking about. Fail. If you say schema merge equals true, it will try to merge the schemas. But it may fail because if you do something where you're trying to put like a number into a text defined columns, that would be a potentially merge safe, right? So if I'm putting a number into a text column, that might be merge safe. You change the data type of the column to text, and then numbers and text can fit there. However, if you're trying to put a text thing into a number column, you may not, it may fail because of the way it's trying to merge those data changes together. So just be aware of what those two features mean. They're very important. And we're kind of glazing over them here a little bit. We don't have examples around that, but just be aware that those are two really important features you should understand when you're writing and creating delta tables. What is the overwrite option or append? And then what is the merge schema option? Sorry, I didn't mean to go there. You already loaded the data super fast.
Yep. Sorry about that. We could get into all kinds of things about data engineering. We could talk about upserts if we want, but that would be a whole different episode. So, all right. So, as we can see, this is something nice that Michael Kowalski, the author of the Semantic Link Labs, has put in here. Basically, when these functions run, they output this little information down here to let you know what it did. And so, if you're doing logging, you can actually have this stuff show up in your logs, which is cool. All right. So next, we're going to come down here and we're going to read the data out. But let's make sure that it actually showed up where we think it's going to be. So we're going to refresh the tables here. Oh, look at that!
There we go.
Hey, cool.
Tables.
All right. So we can actually look and see that those columns are there.
Yep.
Yeah, and we see that the data types are what we expect them to be, right? So that's good. Cool. So let's go ahead and get them loaded back into data frames so we can start playing around with them basically sort of doing the opposite, pulling data out of a delta table and putting it into a data frame instead of the other way around. So we're going to start with just getting the path to where these tables are. Storage options here. This is what allows basically us to get the data out of these tables here, because they're in Fabric, and we need to use the Fabric basically built-in credentials to get that.
Now, James, real quick, before you move on too far past that one, so the ABSF base path, like, how would I get that? Like, that's like a very long, stringy looking thing. So
right.
Just point to me, like, where would I have the table. How do I go get that path? Where would I find it in the UI?
So I just used this. I told it to load the data, and what that does is it spits out this
perfect
code right here, and I just stole that ABFS path from here.
Correct.
And I shortened it a little bit, because what I ended up doing up here is I took because at the very end of this path it actually gives the explicit name of the table that it wants to load. So I took everything up to that and made that a variable, and then I'm going to append the table name to it later. So
perfect.
This is the dry principle. Don't repeat yourself.
Yes, it is. Oh, one more thing too. I want to also point out one more other item here. If you just want the ABSF path of the table, like not the whole litany of code of like how to read the data in, you can also go directly to the ellipsis of dim bar. So if you go back over to ellipsis there, click on it and just copy the path. So if you copy path there and then just paste it anywhere you want, James, and that'll just show you that is the same line of code for the ABSS path as well. So you can also get just, ABFS path stands for something's file storage system or something like that. Azure something file
Azure
storage
blob,
system.
something.
File storage system. I'm going to go. Maybe that's right. I don't know. Don't quote me on this one. But the idea is that's the physical location of where those files exist on I think of it on disk in the cloud somewhere, and that's where they are stored. So just be aware that's how you get that actual path, and you can get that per table if you need to. Sorry, go ahead. Keep going, James.
Yep. Okay, cool. So now that we've got this is the base information that it's going to need, both of these pulling data out of both of the tables is going to need the same stuff. So we only declare it once. So what we're going to do here, like I said before, we create the full path for the dim table by just concatenating the base path plus dim bar. Same thing we're going to do in here with factfoo. And then for the delta table, we go to tell it to, here's the path for that table. And then it uses the storage options, which is this thing that we have up here, right?
Yep.
So again, we're declaring it once and using it more than once. And then one more thing down here, we're going to say, all right, so we're pulling the data out. We're going to say this here, the delta table dot to pi arrow data set dot head, and this is going to take the first 10 rows. Fortunately, our dim bar only has 10 rows, and then this is going to turn it into a pandas data frame here. Same thing down here with we're going to take 50 rows. That's the number of rows that this fact table has. And that's it. And this statement here is basically saying it's just going to show us what it looks like. So we'll go ahead and run this.
Awesome. Yep. Perfect.
And there we are.
Perfect. And that's kind of our demo for today. Just kind of a quick little run through of this particular function, showing you how you use it, how you can leverage it. It's going to show you how to get data written into the Lakehouse. And we may follow up. James and I were talking offline about this. Everything we're doing inside this notebook is 100% a part of the Python notebooks. This is a pure Python notebook.
Yep.
It's running on a single machine. There's no cluster behind this. We're not talking, a whole Spark cluster. So what we may do in the future video is we may redo this example here again, but instead we would use it for PySpark. So you can see how somewhat of the language changes, but a lot of it will be similar as well. All right.
Yep.
That being said, thank you all so much for our quick demo today. We appreciate your time. I hope you found some valuable, useful information around working with Semantic Link Labs inside your notebooks. We hope you enjoyed this and many more to come. James, thanks so much for doing the demo today.
Thanks, Mike. See you all later.